Hi guys, Marketa here. Today we're going to look at graphing linear equations, and before we do that we want to just have a brief overview of linear functions. So y equals mx plus c is the general form of a linear equation. So over on the right we see that we have a straight line graph, and that is in the form of y equals mx plus c. C is our y-intercept. It can be positive, but it can also be negative. The y-intercept is where the line cuts the y-axis. It's that point there. M is our gradient. That is the slope of our line. It is not the x-intercept. The x-intercept is where the line cuts through the x-axis. We don't get that value from our basic form of y equals mx plus c. We have to be familiar with y equals mx plus c, and from this we can easily sketch graphs using the y-intercept and gradient method. Don't forget that when you do linear graphs, you want to label your axes with y and x. You can see it done there. We would also want to have arrows at the end of our axes, and we would put the equation on the line once we learn to do that. Now let's look at gradient. Let's have a think about what the gradient actually means. So just say you're walking up a hill. That is represented by the graph here. The line goes from left to right. It looks like you're walking up a hill. That's a positive gradient, going up. Just say you're at the top of the hill and it's flat. So you're not going up and you're not going down. That's a zero gradient, and it's represented by a straight line which cuts the y-axis but is parallel to the x-axis. That's zero gradient. Finally, if you're walking down the hill, you can see that the slope is therefore going downwards from left to right. That's a negative gradient. We also know that the gradient is rise over run. Rise being how many units we go up, and run being how many units we go across. We can also have a gradient which is undefined. Let's now sketch some graphs in y-intercept and gradient form. So here it's telling us to sketch the graph of y equals 3x minus 7. We want to state the information that we have. Thinking back to our general form of y equals mx plus c, we know that the y-intercept, or c, is negative 7. The gradient is our m value. That's what's next to the x, and in this case it's 3. Gradient is rise over run, so let's write that 3 in a fraction. Anything divided by 1 is going to be itself, so 3 divided by 1 is 3. 3 written as a fraction is therefore 3 over 1. And it's handy because it tells us what the rise and run are. We can now plot the graph. Here it is here. Down there we have the y-intercept, where the line cuts the y-axis. It's at negative 7, as we saw from the c value. We then have another point. This is at 1 and negative 4. How I got this was to say, from the y-intercept, we're going to rise 3, because 3 is our rise value in the gradient. We go from negative 7 up, negative 6, negative 5, negative 4. That's up 3. Then we run, or go across, positive 1. So we're going in the positive direction of the x-axis across 1 unit. So the coordinates of that unit would be 1 and negative 4. That's our second point, and by connecting those points we can draw the graph. We always want to write the equation of the line on the line, and we want to label the x and y axes as is shown there. Now let's try to sketch the graph of y equals negative 3x minus 7. We want to first state the information. That's the first step. So the y-intercept, or c, is negative 7. The gradient is now negative 3, because where our m is, it's negative 3. let's state that as a fraction, because then it is in rise over run form. Now, negative 3 is either 3 divided by negative 1 or negative 3 divided by 1. It doesn't matter which way you do it, you're still going to get a point which lies on the line of negative 3x minus 7. As long as you only have one negative though. If you have two negatives, a negative divided by a negative is a positive. So if we had negative 3 over negative 1, that would be positive 3. And that is not our gradient in this case. Secondly, let's plot the graph. Here it is here. There's my y-intercept of negative 7. And now I have a point of negative 1, negative 4. Let's think about how I got that. So from the y-intercept, we rise 3, negative 7, negative 6, negative 5, negative 4. That's my rise. My run is this time negative 1. So negative 1, I go 1 unit to the left on the x-axis, in the negative direction of the x-axis, taking me to negative 1. So the point negative 1, negative 4 is on that line. I write the equation on the line, and I don't forget to label my x and y axes. Don't forget that negative divided by negative is positive, and negative divided by positive is a negative, and vice versa. That's important for when you're writing a gradient in fraction form. Now, we want to look at intercepts, and we're going to learn to sketch graphs using the intercept method. First, let's think about what intercepts actually are. Here is a linear graph. We have an x-intercept and a y-intercept. What do you notice about the x-intercept? So the x-intercept is this value 0.60. What do we notice that is similar about the y-intercept? It is 0, negative 3. See how there's a 0 in each of those? When y is 0, that is our x-intercept. It means that we don't go up or down at all. We're just on the x-line. So that's an x-intercept. A y-intercept is where x is 0, as shown in our coordinates. If x is 0, we don't go to the left or right. We just go up and down. And in this case, the y-intercept is negative 3. There they are. So an intercept is where the line cuts the x or y axes. At the y-intercept, x is 0, and at the x-intercept, y is 0. This is really good to know and is something you must remember, especially when drawing graphs using the intercept method. So let's do one now. So we want to sketch the graph of 2x plus 8y equals negative 20, and we're going to use the x and y intercept method. Even if it didn't tell me to use the x and y intercept method, I'd know to do that because it's not in y equals mx plus c form. When it's in y equals mx plus c form, the easiest thing is to use your y-intercept and gradient method. So step 1, let's find the x-intercept. What do you remember about the x-intercept? Well, at the x-intercept, y equals 0. Let's state that. Let's now substitute y 0 into the equation. So negative 2x plus 8 times 0, notice how I use brackets, equals negative 20. I then solve for x, so negative 2x equals negative 20. Negative 2x divided by negative 2, there should be a negative there, equals negative 20 divided by negative 2. I divide by negative 2 on both sides. That gives me x equals 10, because negative 20 divided by negative 2, negative divided by negative is a positive. So my x-intercept exists at the point 10, 0. X comes first, y comes second. Don't forget to highlight or circle that. We then find the y-intercept. What do you remember about the y-intercept? At the y-intercept, x equals 0. So we substitute x is 0 into the equation. Negative 2 times 0, note the brackets, plus 8y equals negative 20. 8y equals negative 20. Divide by 8 on both sides, leaves us with y equals negative 5 on 2. It's a fraction, and that's okay. So our y-intercept is at 0, negative 5 over 2. You might like to put that as a mixed number, but you wouldn't put it in a decimal. The third step is to actually sketch the graph. Don't forget this step. Here it is here. I've got x-intercept at 10, 0. So you can see it's marked on there. And the y-intercept at 0, negative 5 on 2. You should probably make a dot at each of those points. I've also labelled my x and y axes, and I should have the equation on the line. The last thing we need to do is to be able to transpose an equation. So transpose these equations to standard form. What that means is that we want to put it in y equals mx plus c form. So 10x plus 5y equals negative 150. So let's state the form. So you would write y equals mx plus c. This shows that you know what standard form actually is. We then just rearrange our equation. 5y equals negative 10x minus 150. I've taken the 10x to the other side. I'm then just going to divide by 5 on both sides. Don't forget that you need to divide everything by 5 on the right as well as the left. Finally, I get y equals negative 2x minus 30. That is now in standard form, and that is your answer. How about this one here? We have brackets. We need to expand the brackets. Let's first state the form. Y equals mx plus c. So 8 times y is 8y. 8 times negative 5 is negative 40, equals negative 4 times x, negative 4x. Negative 4 times 3 equals negative 12. Let's rearrange. I'm going to take the negative 40 over the other side, where it becomes plus 40. 8y equals negative 4x minus 12 plus 40. So 8y equals negative 4x plus 28. Let's divide by 8 on both sides, leaving me with y equals negative 4 on 8, which is negative a half, x, plus 28 on 8, which simplifies to 7 on 2. And that's it. That's how we transpose the equations into standard form. We want y as the subject, not negative y, not 3y, just y. And we want it in the form y equals mx plus c. That's it, guys. That's all you have to know for the first exercise.